Hello and welcome to Conditional Probability. Here we're going to look at how to find problems that are and problems when the events may not be independent. Consider some data from a previous class. We tallied how many boys in the class were wearing sneakers, how many girls in the class were wearing sneakers like tennis shoes, how many were not wearing sneakers like sandals or something else like that, flip-flops. So the first thing you do with a problem like this is to find the totals. First we need to tally it. So we'll go, there are 14 wearing sneakers, 14 not wearing sneakers, so that's 50-50. There were 14 boys and 16 girls, a total of, 12 boys, and 16 girls, a total of 28 total students. What's the probability that a student is wearing sneakers? So this is probability of sneakers. So I need to look at all the people wearing sneakers. There were 14 of them out of 28. So probability of sneakers is 14 out of 28, which is 1/2, which is 0.5. We use decimals here. What's the probability the student is a girl? Probability of being a girl, I'll just do this. How many girls are there? 16 out of 28. So if I take my calculator on this one, 16 divided by 28, 0.57. Now, we know from if they're independent events, then A times B equals the intersection of A and B. Does that work here? Probability of wearing sneakers times the probability of being a girl. That is 0.5 times 0.57, which is 0.285. Well, is that really the answer to the probability of both wearing sneakers and being a girl? We know from our data that there were 4 of those people out of 28. So the real answer for this is 4 out of 28. And if I divide 4 divided by 28, that is 0.142. So this doesn't match. It's not equal to it. So A times B does not equal the intersection of A and B. Therefore, they are not independent. Now, I was still able to come up with the answer here from the data, and we're going to look at how to do that in these kinds of problems. Conditional probability is A given B. And the notation here is we have this big straight line here. A given B. You would read this as A given B. What conditional probability says is basically saying, if you see this notation, it means out of this group, if I already know B about the person, what's the probability that A happens? So if I take all the people for which B is true, and we put them all in a room, now out of those people, if I choose one person, what's the probability that I get A? So this is a problem dealing with people's preferences for where to hold prom, and what kind of music that they like. So the first thing to do, again, is to total. So we'll go 73 plus 55, and that gives me 128. And we'll go 80 and 92, which is 172. 73 and 80 is 153. 55 and 92, 147. So if I total these guys and I add them all up, I got 300 total students. Okay, now let's see if we can answer some of these questions. What's the probability that somebody prefers a hotel? So now it doesn't matter what kind of music you like, just do you want the prom held at the hotel? Well, there were 128 of those people out of the total 300. So our answer here is 128 divided by 300, and that is 0.4266. The next one, what's the probability that somebody, if I choose one of these 300 people, what's the probability if I ask them that they say they prefer hip-hop? Well, there were 153 people out of the 300 that preferred hip-hop. So 153 out of 300, that looks like it's about 50%. That is 51%. Now, what's the probability that the person, if I ask them, that they'd say they prefer the hotel and hip-hop music? Well, that would be these people here, hotel and hip-hop. That is 73, we'll do it over here, 73 out of the 300 still. Because I'm selecting a person at random out of the 300, and I'm asking them, do you prefer hip-hop and hotel? If you can answer yes to both of those, 24% will answer yes to both of those questions. Now this one prefers a hotel or prefers hip-hop band. So now they have to answer yes to one of those questions. So we've learned how to do this before. We say, okay, let's take all the hotel people, all the people that like hotels, there's 128 of those, plus the people that like hip-hop, which there are 153 of those, but we have double counted the people that both like the hotel and the hip-hop. We counted it here and we counted it here. So we need to subtract away those 73. And this is again out of 300. So what's that? 128 plus 153 minus 73 divided by 300. And that is 69.3%. Now here's the new stuff. Prefers a hotel given, this is a given bar, given that they prefer hip-hop. So if we ask them a question first, do you like hip-hop? Now if we had all the people that like hip-hop, there's 153 of those. Out of those people, what's the probability we ask somebody there and they prefer the hotel? So that would be 73 out of the 153. So 73 divided by 153. And that is 0.477. And the last one, what's the probability that you prefer hip-hop given that you prefer a hotel? So if we know that you prefer a hotel, you're one of these people, one of these 128, what's the probability that when we ask you, you'd say, I like hip-hop music? So there were 73 people in the hotel group that like hip-hop music. So 73 divided by 128. That is 0.57. That's how conditional probability works. What's the probability that you like hip-hop given that you like a hotel? Well, that's out of the hotel people first. What's the probability that we find somebody that likes hip-hop? Have a great day.